Hello, today we're going to continue on quadratics. We're going to work on vertex form. What is vertex form, and what does this expression or function look like, and how can that information in that expression slash form can give us some useful data to help us graph and then describe the characteristics of the parabola. So we're going to start off by, that's our main question today, is vertex form. Again, vertex means it gives us the vertex in the function. So the vertex is given to us. Our goal is just to go ahead and pull out the vertex and then describe the characteristics. Again, we have the a value. The a value hasn't changed. It's still going to give us whether it's going to be, a stretch, or a shrink. So again, narrow or wide. So the a is going to do the same thing. Also, if there's a negative in front of the a value, again, we open up. If it's if it's going to be positive a, we open up. If we have a negative a value, it's going to open down. And then aside from that, we're going to talk about odd, even functions. So even functions are going to be functions that have the highest degree be even. So power of 2, power of 4. So again, those are even numbers. And right now we're going to be working with parabolas, quadratics, and so those are going to be even functions, and they are symmetric about the y-axis. So we have mirror images across the y-axis. We have odd functions. Okay, odd functions are the highest degree is going to be 1. So we have a degree of 1 there, a degree of 3 there. And just to give you an idea here, this is going to resemble y equals negative x. When we go down 1 over 1, it's going to be linear. Y equals x to the third power, x cubed is going to be a cubic function, and it looks sort of like an x. And these guys, what they have is they have symmetry about the origin. So we have symmetry about the origin. Over here, again, we have symmetry about the origin. So we have some symmetry across, the origin. In the earlier slide, we showed the vertex is given to us, and b equals h and k, and that's how we find the origin. Now, when it comes to the times of graphing, in terms of graphing this, you always start at the origin, and then depending on my a value is going to tell us those first 2 points. So if the a value is 1, we go up 1 over 1, and those are our first 2 points to each side of the parabola. If my a value is 3, then we go up a 3 over 1. So again, those very first points on each side, for example, my parabola, okay, those very first points are going to be whatever my a value is. So if my a value is 1, again, my a value is going to be 1, I go up 1 over 1, up 1 over 1. You can do a rough sketch. Okay, if my a value is 3, or let's say 4, okay, let's say my a value is 4. And I go here, right? I go up 1, 2, 3, 4, and then over 1. So again, the a value is kind of your slope for the very first point on each side. Only for those first points. So let's continue here. Horizontal shift. So the h value here determines whether we go to the left or to the right. Okay, to the left or to the right. So given that this guy is responsible for moving the graph to the left or to the right, and that's what's going to tell us whether we're going to go to the left or to the right. Now, the h value is going to help us do this. So let's go ahead and give an example. If we have f of x equals x, let's pick a few h values. X squared plus k. Okay, we're going to leave my k alone right now, but we're going to pick a few h values. We're going to pick h value of -2. We're going to pick the h value of +2. We're going to see what these h values tell us that's going to happen to this graph. Okay, so if we plug in this h values, we're going to plug in, let's say, so let's turn to the positive. So again, if it's negative, we have it's negative, we're going to go over 1, 2, negative 2. So we're going to shift over. To the left 2. So now again, when we simplify x plus 2 squared plus k, okay, we shifted it over to the left. Now we can go ahead and graph this. Okay. Now let's try again. Well, this time let's try a different input. Let's try the positive 2. So the positive 2 positive 2, different color. So the positive 2 is going to tell us that we're going to go over and this should be the same width. I'm not trying to make one more narrow than the other. This is not to scale as far as width goes, but it is to scale as far as the units, which way we go, to the left or the right. So I guess the idea here is when you have the symbol on the inside, again this is going to be minus 2. I boxed those two up because when it's positive, right? When it's positive, you go to in the opposite side of the origin. Again, this is my x-axis. So in terms of my x values, really what my h value is telling you is how many units we shifted over on the x-axis. So notice when it's positive 2, we actually went to the left 2 units. Why is that? It's because my h value to begin with was negative 2. So down here, we have negative 2. So when it's negative 2, we went over to the right 1, 2 units. Because my h value to begin with was 2. So really, we need to know that my h value determines whether I go to the left or to the right. One thing that students get wrong a lot is because when they see a positive 2, automatically say, hey, it's positive 2, it means we're going over to the right, to positive 2. Okay? That would be wrong, because my h value originally was negative 2, which means that we have to go to the left 2 units. Same thing down here. Students see, oh, it's negative 2. Okay, my h is negative 2. No, right? My original h value was 2. So the idea here is you always move in the opposite direction when I'm asking you for a shift. So I'm asking you, hey, which way did we go? If it's positive 2, we went over to the left. If it's negative 2, we go over to the right. Okay, so that's the big thing about the h values in this slide. Okay, another vertex form. We're talking about the k value. My k value actually tells us it tells us whether we go up or down. That's my k value. So whatever the value here is, we go up or down. So for example, if we have, we're going to talk about k value. Let's say k value equals plus 2, and my k value equals minus 2. How would that look like? We're not going to mess with the h right now. We're going to leave it alone. But if we were to go ahead and say, hey, this is going to be f of x equals, let's say, plus 2, and we're going to say f of x equals a of x. We're going to say minus 2. It's not minus 2. Okay. So what I'm doing here is when you plug in your k value, this is going to tell us whether we go up or down. So this guy tells us whether we go up or we go down. And so when you go ahead and plug in your k value, if you want, you just know that, hey, If it's plus 2, we're going to be, from the origin, we're going to go up 1, 2. We're going to start there. And if it's positive, we're going to open up. Okay, positive 2. If it's minus 2, well, guess what? We're going to go down 1, 2. And we're going to say it's positive, so we're going to open up. So the key takeaway here is the K value indicates the true value of whether we're going to go up or down. As opposed to the earlier slide, the H value can be a little trickier because of the negative symbol. Let's do some problems here. We're going to do 2. F of x equals 2x minus 4 squared plus 2. We're going to do that one. We're going to do another one. It's going to look like, let's say, we're going to call it g of x equals, let's say, 3x. Let's say, we're going to go positive 4. Positive 4. Why not? And then minus 2. Okay? So we're going to graph these. We're going to do a rough graph just by finding the vertex and also the transformations based off my h value and my k value, not to mention my a value. Okay? So we're going to say, how do we graph this? Well, where do we start? We start with my vertex. What's my vertex here? Or what's my h, my k? So my vertex here would be, again, my h and my k. My h and my k. So my h is negative 4, so that means it's going to be a positive 4. My k is going to be 2. So where's my vertex? We're going to go, again, I said we're always going to move in the opposite direction. So if it's minus 4, we're going to go 1, 2, 3, 4. And we're going to go up 2. 1, 2. So we're going to be here. My a value is 2, meaning I'm going to go up. I'm going to go up 1, 2, and then over 1. Up 2, over 1. And you just go ahead and graph. And again, those first points, right, are always determined by your first a value. So if your a value is 2, just treat it as slope. But only for those 2 points, right? Only for those first 2 points. That's it. Over here, we're going to kind of do the same thing. We're going to say we're going to go ahead and graph this. Find my vertex. Okay, what's my vertex? Well, again, what's my h and what's my k? My k is minus 2. My h is going to be plus 4, which means it has to be a negative 4. And so we're going to go down 1, 2, 3, 4. So negative 4. And we're going to go down 2. We're going to go down 1, 2. Which means that my vertex is going to be right there. Okay, that's me, my vertex. And I'm going to open up because it's positive. Now again, that first point is going to be 3. So we're going to go up 1, 2, 3. Right? 1, 2, 3, and over 1. Up 1, 2, 3, and over 1. Only for that first point, guys. Only for that first point. And then we just go ahead and we graph. Again, we're graphing by just using the a value, the h value, and the k value, a rough sketch. So the idea behind this is know how to give a rough sketch of a parabola. Now, if you want to draw an accurate graph of a parabola, more than just the first 2 points in the vertex, if you want more than 3 actual coordinates, what you do is you do the old school way. Make a t-chart, right? Your x values, your y values, your inputs, your y values. And then the idea behind this is, where do you start, right? Where do you start, right? You always start here because that's your vertex. That's your vertex, and we start there as far as values to the right, values to the left, because when you graph a parabola, you want to have, both sides. So you pick points that are going to be to the right-hand side and to the left-hand side of your parabola. So other than that, if you're going to do it old school way, and I say, hey, graph this and make sure you have at least 3 points to each side, well, always start at your vertex. Always start at your vertex. Okay? And then you do points to the left and the right. And this is how it would look like here.